morning students, how are you? 12th physics. Today we see about the electromagnetic induction and alternating current, unit 4. At the topic, now we discuss about the topic of AC generator. AC generator. In previous class we see about the production of induced EMF by changing the relative orientation of the coil with the magnetic field. Then we see about what is induced EMF and mutual induction. What is mutual induction? What is mutual induction? The electric current that passes through the coil changes. There is some changes in the time, and the EMF is induced in the neighboring coil. This phenomenon is known as the mutual induction, and the EMF that induced is called the mutually induced EMF. This is the mutual induction. Then we see about the self-induction of a long solenoid. Then we see about the eddy current. What is meant by eddy current and eddy brake? Lenz's law states that the direction of the induced current is such that it always opposes the cause that is responsible for its production. What is the formula for Lenz's law? Epsilon equal to minus d n pi b by dt. Then today we discuss about the AC generator. AC generator or alternator is an energy conversion device. It is an energy conversion device. It converts the mechanical energy into electrical energy by using these two magnets. It is a energy conversion device. AC generator is an energy conversion device. It converts the mechanical energy into the electrical energy by using the magnet. It converts the mechanical energy used to rotate the coil, this rectangular coil or a field magnet into the electrical energy. So it converts the mechanical energy into electrical energy. Here, the alternator produces a large-scale electrical power for use in homes and industries. Alternating current uses in our homes and industries. It produces a large scale of the electrical power. Then some components of AC generators are given in our textbook. See the figure 4.26. Here the AC generator and its components. Here the first one is stator. Then the second one is rotor. Then the alternator. Then breast box. Then slip rings. These are the components that are present in the AC generator. Then we discuss about what is the principles involved in the AC generator. Here the alternators work on the principle of this is the alternator. These alternators work on the principle of electromagnetic induction. It works on the principle of electromagnetic induction. What is electromagnetic induction? What is electromagnetic induction? Whenever the magnetic flux that linked with a closed coil that changes and EMF is induced, and hence the electric current flows in the circuit. This current is called an induced current, and the EMF giving rise to such current is called the induced EMF. This phenomenon is known as the electromagnetic induction. Whenever the magnetic flux that linked with a closed coil, that changes an EMF that is induced, and hence the electric current flows in the circuit. This current is called the induced current, and the EMF giving rise to such current is called the induced EMF. This phenomenon is known as the electromagnetic induction. In AC generator, the alternators that work on the principle of this electromagnetic induction. Then the relative. Here the alternators work on principles of AC generator. Alternator work on the principle of electromagnetic induction. Are you understand? Then the relative motion between a conductor and a magnetic field changes the magnetic flux linked with the conductor, which in turn induces an EMF. Then the magnitude of the induced EMF is given by the Faraday's laws of electromagnetic induction. Here it's the directions by Fleming right-hand rule. By direction by Fleming right-hand rule. Here the relative motion between a conductor and a magnetic field changes the magnetic flux that linked with the conductor, which in turn induces an EMF. The magnitude of the induced EMF is given by the Faraday's laws of electromagnetic induction, and the direction of current is given by the Fleming's right hand rule. What is Fleming's right hand rule? Take our right hand and stretch the fingers, the thumb finger and the index finger and the middle finger. Here the thumb in perpendicular direction. Place the finger in a perpendicular direction. If the index finger points the direction of the index finger, this one is the index finger, this index finger points the direction of the magnetic field. This index finger points the direction of the magnetic field. Then the thumb indicates the direction of the motion of conductor. Thumb indicating, here this is the thumb. This thumb indicates the motion of direction of the conductor. Then the middle finger will indicate the direction of induced current. Middle finger indicate the direction of induced current. This is the Fleming's right hand rule. Take the right hand and stretch the fingers in a perpendicular direction. The thumb finger, index finger and the middle finger. Here the index finger points the direction of magnetic field, and the thumb indicates the direction of motion of electric conductor. Then the middle finger indicates the direction of induced current. This is the Fleming's right hand rule. Here in our AC generator, what is the principles involved in AC generator? Here the alternators work on the principle of electromagnetic induction. Then the relative motion between the conductor and a magnetic field that changes the magnetic flux that link with the conductor, which in turn induces an EMF. Then the magnitude of induced EMF is given by the Faraday's electromagnetic law of induction. Then the direction is given by the Fleming's right hand rule. This is the principle involved in AC generator. Here the alternating EMF is generated by the rotating coil. Alternating EMF is produced by the rotating coil. This is a rectangular rotating coil. Here only the alternating EMF will be produced. EMF is generated. Then or by rotating a magnetic field with a stationary coil. Then the first method is used for small AC generator, while the second method is employed for the large generator. The rotating field method is the one which is mostly used in power station. Rotating field method is mostly used in the power station because they produce in power station they produce a large amount of current, so they use the rotating field method. Then we see about the construction of AC generator. Here the alternator consists of two major parts, stator and the rotor. Alternator consists of the two major parts. What are they? Stator and rotor. This alternator consists of two major parts. What are they? Stator and rotor. These are the two major parts that present in the alternator. Then, as the name suggests, stator is a stationary while rotor rotates inside the stator. Stator is a stationary. If we need, then only it will be placed, or otherwise it will be removed. So it will be a stationary one. Rotor that is placed inside the stator. The rotor will rotate the stator. Then, in any standard construction of commercial alternator, the armature winding is mounted on stator and the field magnet on rotor. The armature winding is mounted on stator and the field magnet on rotor. Field magnet, this is the two magnet that present in the AC generator. This is the field magnet on rotor. Then first we see about the stator. Here the stator, already I said, stator is a stationary part which has the armature winding. Mounted in it is called a stator. It has the two components. The stator has two components. What are they? Stator core and armature winding. Stator has the two components. What are they? stator core. Stator core and armature winding. Armature winding. These are the two parts that present in the stator. Then the stator core or armature core is made up of the iron or steel alloy. These two, stator core and armature core, are made up of the iron or steel alloy. Iron or steel alloy. It is a hollow cylinder and is laminated to minimize the eddy current loss. It is a hollow cylindrical shaped structure. It is used for to minimize the eddy current. It is used for to minimize the eddy current loss. Then the slots are cut on inner surface of the core to accommodate the armature winding. Armature winding is the coil wound on slot provided in the armature core. See the page number 224, figure 4.27, stator core, armature winding and 2-pole rotor. This is the diagram for the stator core, armature winding and 2-pole rotor. Here there is the armature slot in the above, then the round structure, that is called the stator core, and below inside that there is the slip rings are present. Then the magnetic axis of the field. Then there is a coil-like structure, that is called the field winding. Then DC source, that the two brushes are present in that slip rings. These are the structures of stator core, armature winding and the 2-pole rotor. Then we see about the rotor. In stator, what are the things are present inside the stator? Stator is a stationary part which has the armature winding mounted in it, that is called the stator. It has the two components. What are they? Stator core and armature winding. These are made up of, it is a hollow cylindrical shaped structure that is made up of the steel or iron alloy. Then we see about the rotor. Here the rotor contains magnetic field winding. The magnetic poles are magnetized by the DC source. Here the magnetic poles, the two magnetic poles are magnetized by the DC source of current. These two magnets are magnetized by the DC source of current. The ends of field windings are connected to the pair of slip rings. The ends of these two field rings are connected to the pair of slip rings. There is a pair of slip rings are present in the AC generator at the end position. Then it is attached to a common shaft about which rotor rotates. Slip ring rotate along with the rotor to maintain the connection between DC source and the field winding. Two brushes are used which continuously slide over the slip rings. Then the two brushes, carbon brushes, are continuously used along with the slip rings. Then the 2-pole rotor, we will discuss the construction and working of two examples, namely single phase and 3-phase AC generator in the following section. Next we discuss about the single phase AC generator and the 3-phase AC generator. Before that, we see the advantages of stationary armature rotating field alternator. Advantages of stationary armature rotating field alternator. Alternators are generally high current and high voltage machine. Alternators are usually a high current and high voltage machine. The stationary armature rotating field construction has many advantages. Few of them are given in your textbook. What are the advantages? The current is drawn directly from the fixed terminal on the stator without the use of brush contact. In the armature rotating field alternator, the current is directly drawn from the fixed terminal on the stator without the use of the brush contact. Then the insulation of stationary armature winding is easier. Then the number of sliding contact, that is slip rings. Sliding contact means slip rings. The number of slip rings is reduced. Moreover, the sliding contact are used for low voltage. Then the armature winding can be constructed more rigidly to prevent the deformation due to any mechanical stress. The armature winding can be constructed more rigidly to prevent the deformation due to any mechanical stress. These are the advantages of stationary armature rotating field alternator. What we see about the AC generator. Before that, we see this is the structure of the AC generator. Here the two ball magnets are present. Between that, rectangular coil is present. Below the rectangular coil, it is joined with the slip rings. The two slip rings are connected with the carbon truss. Here this is the flow of current direction, that is the Fleming's right hand rule direction. What is AC generator? It is an alternator energy conversion device. AC generator is the alternator energy conversion device. Here it converts the mechanical energy into the electrical energy with the use of rotating coil on the field magnet. The alternator produces a large electrical power, so it will be used in the homes and industries to produce the large amount of current. Then what is the principles involved in the AC generator? Here the alternator that work on the principles of electromagnetic induction, the relative motion between the conductor and a magnetic field that changes the magnetic flux that linked with the conductor, then which in turn induces an EMF. The magnitude of induced EMF is given by the Faraday's laws of electromagnetic induction. Then it is direction, the flow of current direction is given by the Fleming's right hand rule. Then we see about the constructions of AC generator. Here the alternator consists of the two major parts. What are they? Stator and the rotor. Here the stator is the stationary part. Stationary part means if we need, it will be attached. If we do not need, means it will be removed. But the rotor, it is present inside the stator, then only it will be rotated. Here the stator consists of the two parts. What are they? Stator core and the armature winding. These two parts are made up of a steel or iron alloy. It is a cylindrical hollow shaped structure. Then rotor contains the magnetic field winding. The magnetic poles are magnetized by the DC source. These two magnetic fields are magnetized by the DC source of current. Then the ends of the field windings are connected to a pair of slip rings. The ends of the field windings are connected to a pair of slip rings. These are connected to a pair of slip rings that is attached to a common stem about which rotor rotate. Then the slip ring rotate along with the rotor to maintain the connection between the DC source and the field winding. Therefore, the two brushes are used which continuously slide over the slip rings. The two brushes are used that is continuously slide over these slip rings. These are the construction and principles involved in AC generator. Then we see about the advantages of stationary armature rotating field alternator. It is used for the insulation of stationary armature winding is easier. Then the number of sliding contact is reduced. Moreover, the sliding contact are used for the low voltage DC source. Then we see about the single phase AC generator. Single phase AC generator. Single phase AC generator. Single phase AC generator. In single phase AC generator, the armature conductors are connected in series so as to form a single circuit which generate a single phase alternating EMF, and hence it is called as a single phase alternator. In single phase alternator, here the armature and the single phase generator, the armature conductors are connected in series. Armature conductors are connected in series. Connected in series so as to form a single circuit which generate a single phase alternating EMF, and hence this is called called as the single phase alternator. In the simplified version of AC generator, a single turn rectangular loop, PQRS. See the picture, figure 4.28. Here PQRS is mounted on the stator. The rectangular loop PQRS that is mounted on the stator. PQRS. North pole and south pole. In the simplified version of AC generator, a single turn rectangular loop PQRS is mounted on a stator. Then the field winding is fixed inside the stator. The field winding is fixed inside the stator. The field winding is fixed inside the stator and it can be rotated about an axis. Here this is the axis. It can be rotated about an axis. This is the axis. Then perpendicular to the plane of the paper. The axis that is perpendicular to the plane of the paper. Then the loop PQRS is stationary and is also perpendicular to the plane of the paper. It is stationary. The loop PQRS is stationary. Then it is perpendicular to the plane of the paper. When field windings are excited, magnetic field is produced around it. Here, the magnetic field B bar is produced around it. Then let the field magnet be rotated in clockwise direction by some external means. The field magnet can be, this is the field magnet, north pole and south pole. It can be rotated in the clockwise direction. Assume the initial position of the field magnet is horizontal. Assume that the initial position. First we assume that initial position means starting position of the field magnet is horizontal. At that instant, the direction of magnetic field is perpendicular to the plane of the loop PQRS. The direction of magnetic field is perpendicular to the loop PQRS. Then the induced EMF. Here the induced EMF is 0. Induced EMF is 0. Okay, students, assume that initial position, the starting position of the field is field of the magnet is horizontal. At that instant, the direction of the magnetic field is perpendicular. Direction of magnetic field is perpendicular to the loop PQRS. Then the induced EMF. Here the induced EMF is 0. Then this is represented by the origin. The graph. Here the graph is taken the omega t is taken as the x-axis and x0 is taken as the y-axis. That is the graph drawn between the induced EMF and the time angle. Here this is the time angle and this is the induced EMF. When the field magnet rotates in the starting position, it will be in the origin position, that is 0. Then the field magnet will be rotated to the 90 degree. Then the field become parallel to the PQRS. This is the field line. This is parallel to the PQRS coil. Then the induced EMF across the PQ and RS. Induced EMF across the PQ and RS will become maximum. So the angle. So here see the graph. This will be maximum at the point A, 90 degree at 90 degrees. Since they are connected in series, because here the armature conductors are connected in the series in a single phase AC generator. Then the EMF are added up and the direction of total induced EMF is given by the Fleming's right hand thumb indicate the direction of motion of the conductor with respect to the field. For clockwise rotating pole, the conductor appears to be rotating anti-clockwise. Hence, the thumb should be pointed to the left. The direction of the induced EMF is at the right angle to the plane of paper. For PQ, it is inward and RS it is outward. For PQ, it is inward and RS it is outward. It is seen as the outward. Therefore, the current flows along PQ RS. The point A in the graph represented here. The point A represents the maximum EMF because here it will be rotated through the 90 degree. Here the axis. Here the axis is parallel to the coil PQRS, so that it reaches the maximum EMF. Then the rotation of 180 degree. Then it will be rotated to the 180 degree for the initial from the initial position. The field again changes into the perpendicular direction, perpendicular to PQRS, and the induced EMF again goes to 0. For 180, the induced EMF reaches the 0. This point is represented as the B. This point is represented as the B. Then the field magnet become again parallel when it rotated at the angle of 270 degree. When we rotate the angle at 270 degree, the plane again parallel to the coil PQRS. Here, it again reaches the maximum induced EMF, but the direction is reversed. Here, it reaches the maximum height at 90 degree. At the same thing, it reaches the maximum height at the 270 degree, but the maximum is take place in the reversed position. This point is represented as the C. Because here it is the current flow. The current flows through the S or QP. S or QP because it is in a reverse direction. So here the current will flow through the S or QP. Then on the completion of 360 degree, the induced EMF again 0 and is represented at the point B. From the graph, it is clear that EMF induced is PQRS in alternating in nature. Therefore, when the field magnet complete one rotation, induced EMF in PQRS finishes the one cycle. This is the graph that taken place between the time angle and the induced EMF. This is the single phase AC generator. Are you understand, students? Again I will go through it. First we see about the AC generator. What is meant by AC generator? AC generator or alternator. It is an energy conversion device. AC generator is an energy conversion device. It converts the mechanical energy into electrical energy by using the alternator, by using the rotating coil and the field magnet. It converts the mechanical energy into electrical energy by using the rotating coil and the field magnet. Here the alternator produces a large scale of electric current, so it will be used in the homes and industries. Then what is the principle involved in the AC generator? Here the alternator works on the principle of the electromagnetic induction. Then the magnitude of the induced EMF is given by the Faraday's laws of electromagnetic induction, and the direction was given by the Fleming's right hand rule. Then we see about the constructions of AC generator. The alternator consists of the two major parts. What are the two major parts? Stator and the rotor. Here the stator, from the name indicate, it is a stationary part. If we need it means it will be attached. If we do not need means it will be removed. So it is a stationary part. But the rotor is placed inside the stator, which rotate the stator. Then these two stator and the stator consist of the two main parts. What are they? Stator core and the armature winding. These two parts are made up of the steel or iron alloy. Here it is a cylindrical, hollow cylindrical shaped structure. Stator and armature windings are hollow cylindrical shaped structure. Then we see about the rotor. In rotor, it contains the magnetic field winding. The magnetic poles are magnetized by the DC source. Here the end of the field windings are attached to the pair of slip rings. Then the slip rings are connected along with the two brushes. Then we see about the advantages of stationary armature, rotating alternator. Here the current is drawn directly from the fixed terminal on the stator without the use of brush contact. Then the installation of stationary armature winding is easier. The number of sliding contact is also reduced in this stationary armature rotating field alternator. Then the armature winding can be constructed more rigidly because to prevent the deformation due to any mechanical stress. And finally, we see about the single phase AC generator. In single phase AC generator, here the armature conductors are connected in series so as to form a single circuit which generate the single phase alternating EMF, and hence it is called the single phase alternator. Here the PQRS, the loop, rectangular loop PQRS is mounted on the stator and the field is winding fixed inside the stator, and it can be rotated about an axis that is perpendicular to the plane of paper. First let us assume the initial position of the field magnet is horizontal. At that instant the direction of the magnetic field is perpendicular to the plane of the loop. Direction of magnetic field is perpendicular to the plane of the loop PQRS. Here the induced EMF is 0. A graph is drawn between the time angle and the induced EMF. Time angle is taken as in the x-axis and the induced EMF is taken in the y-axis. First at the assumed state, at the assumed position of the field magnet is horizontal. At that instant the direction of magnetic field is perpendicular to the loop, loop PQRS. Here the induced EMF is 0 in the graph. Then when the field magnet rotates through the 90 degree, here the magnetic field, direction of magnetic field is parallel to the loop PQRS and it reaches the maximum induced EMF. And this place is called, this position is marked as A. It reaches the maximum induced EMF. Again it rotated to the 180 degree. It is again perpendicular to the plane of PQRS. Again the magnetic field is perpendicular to the coil PQRS. Here it reaches the induced EMF reaches the 0 position. This place is marked as B. Then it will be rotated through the 270 degree. Again the direction of magnetic field is parallel to the plane PQRS, but here the direction of flow of current is reversible process. So it reaches the maximum. It reaches the maximum position at C, but it is a reversible process. Then finally it will be rotated through the 360 degree. Again the horizontal. Again the direction of magnetic field is perpendicular to the coil PQRS. Perpendicular to the coil PQRS. Here the induced EMF reaches the position of 0. Then it is marked as D. This is therefore when the magnetic field magnet complete one rotation, induced EMF in the PQR finishes the one cycle. The induced EMF finishes the one cycle starting from the 0 to it will rotated through the 360 degree. It will be varied. This is the single phase AC generator. Are you understand, students? Okay. Now this is a time for your homework. Before that, I want to clear that point. See the figure 4.29. Above the coil, there will be omega t equal to 0. Omega t equal to 0 means first we apply the 0 degree. Then omega t equal to pi by 2. Here pi, the value of pi is 180. Then 180 by 2. 1 2 is 2. 9 2s are 18. Then 9 90 degree. Then omega t equal to 2 pi. Omega t equal to pi. Pi means 180 degree. So it will be rotated through the 180 degree. Then omega t equal to 3 pi by 2. 3 pi by 2. 3 into 180 by 2. Here 90 into 3. 0 and 3s are 18 and 3s are 27. So it will be rotated through the 270 degree. And finally omega t equal to 2 pi. 2 pi means 2 into 180 degree. So 180 into 2, multiply these two, 0, 16, 3. So it will be rotated through the 360 degree. Do you understand? Today's homework is make 10 fillers. Make 10 fillers. Then study and write the construction of AC generator. Study and write the construction of AC generator. AC generator. This is your homework. Okay students, thank you.